What is up, everyone? Welcome back to another lecture series. Today we are covering chapter 5 on the topic of pressure. So what exactly is pressure? Let's start with an intuitive understanding. Compare a needle against an elephant foot. You might think that an elephant foot is very heavy, so it will exert a very large pressure on the floor. A needle is very light, so it might exert a very small pressure. But that is only one side of the story. We are only looking at it from a force perspective. Pressure is more than a force. Pressure is the force over the area. If you have a very small force, you can still generate a very large pressure if your area is small. Say, for example, the needle. Even though the force that we exert on the needle is very small, but because the area that is in contact with the surface is very small, the pressure can be very high. That's what allows the needle to pierce through the fabric or to pierce through our skin. On the other hand, the elephant, even though the force is very large, the area is a lot larger than the area of contact by the needle. So its pressure would likely be smaller. Let's formally define what pressure is. Pressure is the force per unit area acting on a surface. Let's try an example. Find the pressure acting on the piston if the area of the piston is 20 meters square and the force exerted on the piston is 100 newtons. Pause this video and try to solve it on your own first. So pressure is given by force over area. Let's substitute in the force, which is 100 newtons, divided by the area of 20 meters square. 100 divided by 20 meters square will give us 5.0. The units for pressure is pascals, with the symbol PA. P-A-S-C-A-L. Pascals, spelled this way. When you want to have the units of pascals for pressure, you must make sure that the force is in newtons, and the area is in meters square. In most questions, you will get the area in another unit. Let's say in cm square. That's the most common one. How do we convert cm square to meter square? Very easy. We know that 1 meter is 100 cm. We also know that 1 cm is equal to 10 power minus 2 meters. That means that if I'm going to square both sides, 1 cm squared the whole thing, and square the both sides on the right hand side as well, 10 power minus 2m square the whole thing, then I will get 1 cm square equals to 10 power minus 4 m square. Alright, so let's say in this question here, we didn't get the area to be 20 meters square. Instead, we got it to be 20 cm square. Then to find the pressure acting on the surface of the piston, we will need to do the conversion. So just take 100 divided by 20 times 10 power minus 4 to convert it to meter square. You will get 50,000 pascals. You can see that the cm square is a lot smaller than meter square in terms of the area. So that's concept number 1, using the formula pressure equals to force over area to solve related questions. The second part is to learn about hydraulic systems. Hydraulic system makes use of this property, the property that liquid is incompressible. If liquid cannot be compressed, then when you apply a pressure on one end of the liquid, the pressure increase will be the same on the other side of the liquid. It's best illustrated using an actual hydraulic press that looks like this. You have two pistons. They are of different areas. Let's call this piston A and this piston B. Now, piston A, let's say this is 1 meter square. And for piston B, let's say this is 5 meters square. Let's say we apply a force of 20 newtons on piston A. What is the increase in pressure experienced at this point? The increase in pressure will be the force over area. So 20 newtons divided by 1 meter square, there will be an increase in pressure of 20 pascals. Take note that this is the increase in pressure and not the actual pressure at that point. If you want to find the actual pressure at that point, you have to consider a lot of other things. You have to consider the height of the air column above it. You need to consider the weight of the piston as well. Based on Pascal's principle, we can conclude that there will be an increase in pressure of 20 pascals on this side of the liquid as well. Because liquid is compressible, the pressure will be transmitted undiminished, meaning there won't be any reduction in pressure when it's being transferred through the liquid. That is Pascal's principle. Okay, when a force is applied to one end of the liquid, the pressure is transmitted undiminished to all other parts of the liquid. Okay, very important concept here. That means that this point B will experience a force because every single point along piston B has an increase in pressure of 20 pascals. So what is the increase in force generated by B? We can calculate this using force equals to pressure times area. The increase in pressure is 20 pascals. The area is 5 meters square. So the force generated at piston B is 100 newtons. You can see that when we apply a 20 newtons force on a small area, it actually gives us a larger force on the larger area. This is very useful in hydraulic systems, such as your braking system. We tap on the brakes lightly, but it generates a large force to actually slow the car down. Next, the concept of density. Density is a very simple concept. It just measures the mass per unit volume of an object. As long as an object has mass, it will have a particular density. So density can be thought of as how closely packed the particles are. Usually the solid is the densest, followed by liquid, followed by gas. Because for solid particles, they are very closely packed, which means in the same volume, there's going to be a larger mass. Liquid, usually it is less closely packed. So in the same volume, you will have smaller mass. And gas, needless to say, particles are far apart, so the mass in that same volume will be a lot lower. So density is represented by the symbol rho. Okay, so rho is spelled as RHO. This is a Greek symbol used to represent density. Rho is the same as mass over volume. If you get a question that requires you to find density, just make sure that your mass is kg and your volume is meters cubed. For example, if the mass of an object is 500 kilos, the volume is 0.50 meter cube, then we just take 500 divided by 0.50, and the answer will be 1000. The units will just be kg over meter cube. Because we are taking 500 kg divided by 0.50 meter cube, okay, when we divide the number, we also have to divide the units. Therefore, our units is kg per meter cube. That is for pressure. That is for density. Next concept is for the pressure in a liquid. We have learned how to find pressure in general, just using force over area. If we use that formula, we can actually derive a formula for the pressure of a liquid. Let's learn how to do that. Say, for example, I have a column of liquid, and this column of liquid has a weight of W. We want to find the pressure at the lowest point of this liquid. So what is the pressure here? What we can do is to use the general formula, pressure is force over area, and find expressions for F as well as for A, so that we can find a general formula for pressure in the liquid. The force over here is just the weight of the liquid, because it appears that the weight of the liquid is going to be the one that is pressing down on that bottom surface. The weight over area. The weight can be rewritten as mg, mass times gravitational field strength, and m can be rewritten as density times volume. Remember just now, we said that the density is mass over volume. If I multiply volume to both sides of the equation, I get density volume equals to mass. And this one, I can substitute into mass to give me this expression. Then last but not least, the final step is to take volume divided by area. So it gives us rho hg. The volume divided by the area will give me the height. Because area times height gives me volume, therefore volume over area will give me height as well. Therefore, the formula that we will use for liquids in general is this. P equals to H rho G. You don't have to know how to derive the equation because it will not be tested, but it is good to understand that this H rho G is derived from the definition of pressure. If you deep dive into this equation, you realize that the pressure of the liquid only depends on the height and the density and the gravitational field strength. It does not depend on the area. What they like to test us on is this MCQ. They will have different shaped containers and they will ask you for the pressure at particular points. Say this is filled to here, this is filled to here, this is filled to here, and this is filled to here. Which one has the largest pressure? Definitely the one with the tallest height. Okay, we are looking at the pressure at the bottom of the vase. Because the pressure only depends on the height. It doesn't depend on the base area of the vase. Okay, make sure we understand this concept before we move on to the next one. Because I'm going to teach you how to find the atmospheric pressure as well as the gas pressure using these concepts over here. What is atmospheric pressure? Atmospheric pressure is the pressure due to the atmosphere. And why is that pressure due to the atmosphere? Because in the atmosphere, there are air particles. These air particles will exert a force on you. If you look up into the sky, you don't see anything. But actually, there are a lot of particles that are above you that are pressing down on you. That's why at the sea level, our atmospheric pressure is actually equal to a very large value, 101325 pascals. If you go higher into the mountain, your atmospheric pressure will decrease because there's a small air column above you. If we want to measure the atmospheric pressure, we're going to use this thing called the barometer. How it looks like is like this. You have a liquid here. Usually this is mercury. And then there will be an inverted tube here. And the water will be to a certain level. So this is the liquid. And inside here is vacuum. In a vacuum, the pressure is 0. Just take note of that. The atmospheric pressure is the pressure from the atmosphere. There will be atmospheric pressure pressing down on this part of the liquid, and that causes the water column to rise up. If you bring this apparatus into space where there's no pressure, then the liquid will be the same, at the same level. The concept that we have to use here is the pressure along the same level on the liquid is always the same. If I draw a line like this across any parts of the liquid, I know that the pressure is always the same. Because if it's not the same, then there will be movement of the liquid, which means this point here and this point here has the same pressure. Let's call this point A and this point B. The pressure at A is equal to the pressure at B. The pressure at A is the atmospheric pressure. Alright, slow down. How do we know that the pressure at A is equal to the atmospheric pressure? Imagine that you're standing at A. If you look up above you, the only thing that you're seeing is the column of air that's above you. So this column of air contributes to the atmospheric pressure. That's why we say the pressure of A is only due to the atmosphere, and that is equal to the atmospheric pressure. The pressure at B is only due to the liquid above it. So let's call this P liquid. This is the pressure of the vacuum, which is 0, so you don't have to consider it. The focus here is on this equation. The pressure of the atmosphere is equal to the pressure of the liquid column. So, if I'm able to find out what is the pressure of the liquid, I will be able to know what the pressure of the atmosphere is. And how do we find the pressure of the liquid? Using the formula that we have derived earlier, which is H rho G. So, if I know what is this height of the column, which I can easily measure, if I know the density of the liquid, for mercury, it is usually 13600 kg per meter cube, and G is 10. So I can find the atmospheric pressure. The height is usually 760 mm. So 760 convert to meters, multiplied by 13600, multiplied by 10. That will give me an answer of 103,360 pascals. And this is our atmospheric pressure. Next, how do we measure a gas pressure? The gas pressure can be measured using this device called the manometer. It looks something like this. Let's say we have a gas running here. It is the gas. And then the liquid level is over here. This side is an open end. If it's an open end, means it's exposed to the atmosphere. Use the same principle. Draw a straight horizontal line. Identify 2 points, point A and point B. Point A and B have the same pressure. So write this equation first. Look at point A. What is point A's pressure due to? Point A's pressure is due solely to the pressure of the gas because it's only exposed to the gas. It's not exposed to the atmosphere because it's a sealed tube. So this is the pressure of the gas. And that pressure of B is attributed to 2 things. Number 1 is the atmospheric pressure because it's exposed to the atmosphere. Number 2, it's also exposed to the liquid here. That's why for pressure of B, it's the pressure of the atmosphere plus the pressure of the liquid, both. And once we have that sorted out, we will be able to find out what is the pressure of the gas. Because I can find the pressure of the atmosphere easily. They will either give me the values or they will ask you to calculate using this barometer. Then for the pressure of the liquid, I know the height here. I can measure it using a ruler. I know the density of the liquid. I know G. I can calculate this as well. And that allows me to calculate the gas pressure. So in general, this is the concept that we will need to have. We need to learn how to solve for pressures using this device. Sometimes the gas pressure could be less than the atmosphere. Sometimes it could be more. If it is less, then it's going to look something like this. Okay, you will have the same tube, but the liquid level will be different, probably like this. This tells us that the atmospheric pressure is greater than the gas pressure. That's all from me. I hope this video has helped you to understand pressure a little bit better. If you like the video, subscribe and we'll see you in the next video. Take care.